Hello, welcome back to another episode of Voxel Heist, a series where we'll be going over Unity basics and hopefully by the end of the series have a fully fledged game. Today's episode being collisions, triggers and an interaction system. Today we'll be looking at actually using the interactions we made in the last episode to interact with things in our game world. But first, let's quickly go over the task set from last episode. If we head into our script, it simply just is if sprint and action is pressed and is not crouching, and then we can go to sprint speed. And you'll see that in our game, when we move around we can sprint, but when we're crouched we can no longer sprint. So going straight into what collisions and triggers really are. So we'll make a cube, and we will edit it a bit, scale it inward, up and out to have a sort of a thicker plane. So when I say collisions, collision means two physical objects that are blocking each other. We'll also be looking at triggers. As you can see in our collider here, we'll have isTrigger. What this means is that the two objects can overlap, but they don't physically block each other. Triggers are good with interaction, as if you had a doorway, for example like this, we can have just the collider, the player can walk through, they won't notice anything, but on the back end of the coding, we can then take the interaction from them walking through this door. What we can do is we'll have isTrigger on, and we're going to create a script called Interactable and save that in our scripts folder. We can then go ahead and open that script up and remove all of the default. We're simply just going to add one public void called interact. It's not going to take in any variables, but we will just have a debug log saying this was interacted with. Actually, rather than having this, I'll do the GameObject.name. So the name of the GameObject was interacted with. So now we can try and run this function from something that can interact with it. For example, the player character. So we're going to edit our tryInteract function, and we can do this like so. So we are getting the game object that we're interacting with back in hit from our raycast function. So hit, I can then get the transform. I'm able to get quite a few different things from this. But first I'm going to create a temporary variable called Interactable and get our hits collider, and from that we can get a game or get a component. We're obviously going to try and get our interactable component, as this will be on things that we can interact with. We'll have whatever we hit get its game component or get its component for interactable, and set that to interactable here. We can then check if interactable doesn't equal null. So if we look at something that has a collider but it doesn't have the interactable script or component, this won't execute. And we can simply just go interactable dot interact. You can see we're referencing this function now. And let's see if this works. So at the essence of it, the player controller doesn't care what the object is. It just checks, do you have the interactable component? If yes, run interact. So you can see nothing's happening. But if I go over here and interact, you can see that we get our two messages. Cube was interacted with, which is the name of the cube, and we hit the cube. This is our other debug.log down here, which I can get rid of actually. Before, be sure to exit out of the game. Get rid of that and save, and then recompile the scripts. So I'm going to show you how the difference between triggers and normal colliders. So I'm going to bring this test over here and again just scale it up. Massive. I'm then going to have in interactable, and we can do void on trigger enter. So what this is saying is whenever something enters the collider, it's a built-in function. So the collider other, this will be whatever interacts with the actual collider. So we can simply do if other dot compare tag is player. We can then do again just as a test script. This won't be in the final run of the interactable script, but we can just do object to remove. We can say destroy object to remove. So what we're doing is we're referencing a GameObject because I intend to remove the cube that isn't a trigger. So imagine it's an obstacle in the player's way. When we interact with it, nothing will happen. But when we walk through it, it will destroy it. So in theory, what should now happen is that is no longer a trigger, so we can have our cube be very wide, again acting as though it's an obstacle. So we can't go this way, we can interact with it, but it doesn't do anything. We can now, that is rather interesting. I believe the collision ended up causing the player to rotate somehow, but okay, we'll look into that later. However, if I now walk into here, oh, we need to set the tag on the player as they are currently untagged. We can just add a tag here. So this is how we are referencing this is how we're differentiating between the different colliders that can affect our random test object. So setting the tag up here to player, we can add tags if we wanted to later down the line to differentiate between a whole different array of things. But if I press play, now we should again have the same thing of not being able to move into this wall. We can still interact with it, but if I go over here, we've got set the object to remove, so hopefully it should now do correctly. So again, wall, nothing. Okay, we can test. Debug.log. I'll do other dot tag. Just make sure that did save. Although untagged. I'm going to assume that that could also be the cause. So I'm going to set that to player. And as this is where the actual collider is, so that, there we go. Okay, it was because I had tagged the wrong GameObject, but now we can walk this way. Though I am still curious to why we're slowly rotating. I believe that is purely just because of the rigid body and how collisions are interacting currently. But we will look at different physics materials later down the line to avoid this being an issue. If the player just ran into walls and started spinning, we can also dampen it through our movement script. But that is how triggers are separate from base collisions. So again, if I removed this mesh renderer, I'll actually swap the locations over. So I have the player there and have our test there. If I go ahead and go in, you should now see that when I walk through this way, the door opens. So I'll remove our on trigger enter and our object to remove. Save that, head back over to Unity, and I'll get rid of the test cube and send to the player again. Okay, as this episode is currently shorter than I had planned, I'll show another useful trick, I guess, within, just coding in general. We can set up a small timer for something to happen. I'll put it in the interactable. What we can do is update that. Have a private float. Have this next time. We're going to create a timer. Private float. Current time. Guess 0f. Add a private full timer started equals false. So what we can do is in update we can have if timer started just tidying up a bit. If timer is started, then we will have current time we'll do minus equals time.tail to time. So this symbol here is the same as saying current time minus time.delta time. You may remember we have done something similar to this, like in doing this. However, this only minuses 1, where this minuses a specific number that we would want. And we will say, and later on, if current time is less than or equal to 0, destroy GameObject. And for this to work, we'll need a start. Current time equals max time. And now we can have timer started equals 3. So the logic for this is at the start of the game, we set the current time to the max time, which will be 10 seconds in theory, because we're using time.delta time. If time started, actually I'll put this within here, so then we don't have to run this. because it would constantly be checking this every frame along with checking this every frame. So having this within the if statement, it no longer checks. It no longer checks twice, or two things. So, start the game, current time equals max time. Current time is then set to 10 seconds. If timer has started on the next frame afterward, which will be false, we'll just keep cycling over this. When we interact with it, however, time started will be true, so then we'll have 10 minus time.delta time, which is the time it took to complete the frame. Interval in seconds from the last frame to the current one. So this is a pretty standard way of creating a countdown. If current time is less than or equal to 0, destroy the GameObject. So how this will appear in our game will be as follows. Head over to the wall, interact with it. It's interacted with, and if we wait 10 seconds, I'm not going to fast forward because I want to see how accurate it is. 10 seconds. There we go. You can see that the wall's been destroyed. I can even do a debug.log, get our current time. I can't do it in reverse, but we can do it to string, because this then allows us to format it how we would like. I'll add a bit of just organizing. So what this will do is show our current time, but it'll be rounded to 2 decimal places, along with the actual current time to show you the difference in time.delta time. So heading back over, and let's go. So you can see how it is first with 4.2 decimal places, and then the full float number to many decimal places. And it ended up at minus very small number. But that's just a good way of visualizing countdowns, which we'll get into at some point when we start looking at the different UI or user interface within Unity. But hopefully that has added some extra knowledge that I don't think either of us were expecting for this episode on how to make a timer within Unity. And along with looking at triggers, collisions, and interactions. Okay, with this episode, I'm struggling to think of a task again, as it's mainly covered everything with interactables that we're not going to cover in the next episode. Next episode, we'll be looking at interfaces, which allow you to essentially set templates where you can have different interactables do different things, but using the same script. In theory, as you don't know about interfaces yet, I can't show any homework for that. So this is to the extent of what our interaction system will do. Yeah, I guess just feel free to mess around, maybe do some research into the toString function for floats, which is quite useful. And yeah, thank you all so much for watching, I guess. Please feel free to like and subscribe and check out the links in the description. And stick around for next week's episode where we'll be looking at interfaces and expanding on our interaction system. Thanks so much again for watching. Bye.